This presentation, we want to look at derivatives of exponential and logarithmic functions. Before we look at their derivatives, let's revisit some of the basic properties of exponential and logarithmic functions first. So here's a function, log base b of x. The b is the base of the logarithm, and the x is the argument. Now let's consider this exponential function, b to the power of x. Again, b is the base, and the x is a variable exponent. It turns out that log base b and b to the x are inverse functions. And if you remember from your college algebra classes, that means if you plug one of those functions inside of the other, you should just get back the argument. So it is true that log base b of b to the x is equal to x, and b to the power of log base b of x is also equal to x. Some other properties of logarithms are that x to the power of a plus b is equal to x to the a times x to the b. X to the power of a minus b is equal to x to the power of a divided by x to the power of b. And log base b of x to the power of r is equal to r times log base b of x. So if you look at these three properties, it says that if you raise x to the power of a plus b, then you multiply x to the power of a times x to the power of b. If you're subtracting the exponents, then there's division. And then if there's a power on the variable in the logarithmic function, then that power can come out front. So log base b of x to the power of r is equal to r times log base b of x. So now we'll determine the derivative of e to the x using the limit of the difference quotient and the fact that the limit as h goes to 0 of e to the power of h minus 1 over h is equal to 1. Now e to the power of x is a very special function, and it is an exponential function, just as b to the power of x, but instead of having a base b, it has the base e. And if you recall, e is a constant 2.71 with several places after the decimal. So now we want to look at how we can derive the derivative of e to the x, and we're going to use our difference quotient for that. So derivative of e to the x should be equal to the limit as h approaches 0 of e to the power of x plus h minus e to the x all over h. Because remember, the limit of the difference quotient would take that limit as h goes to 0 of f of x plus h minus f of x divided by h. And that's exactly what we have here. If we use our properties of exponents and we factor out e to the x, and we get that that's equal to e to the x times the limit as h goes to 0 of e to the power of h minus 1 over h. And we should remember from our previous slide that that's equal to 1, and so 1 times e to the x is e to the x. So it turns out the only function that has itself for its own derivative is e to the x, and so the derivative of e to the x is e to the x. Let's look at an example. So let's find the derivative for f of x equals x to the 7th power minus 6 e to the x. Notice that the first term, x to the 7th power, to take its derivative, we'll apply the power rule. And for that second term, to take its derivative, we're going to use the fact that we know the derivative of e to the x is e to the x. So f prime of x then would be 7 x to the 6th power, applying the power rule to the first term, minus 6 times e to the x, because the derivative of e to the x is e to the x. So one might ask, if we can differentiate e to the x, can we use what we have learned to find the derivative of any exponential function, say b to the power of x? And so in order to do this more easily, we're going to add one differentiation fact to our repertoire, and that is that the derivative of e to the power of k times x is equal to k times e to the kx, and this is for k being any constant. So for example, if f of x is equal to e to the 7x, we notice that in this particular case our constant is 7, and so the derivative of e to the 7x would be 7 e to the 7x. So if we could just figure out how to write functions like b to the power of x as the exponential function e to the power of x, we would have it solved. So let's do a little algebra here. So let's let y be equal to b to the power of x. If we take the natural log of both sides, then we get the natural log of y is equal to the natural log of b to the x. And we just need to recall that the natural log of x is the inverse of the exponential function e to the x. Now we'll use a property that says the natural log of b to the power of x is x times the natural log of b. And that'll give us the natural log of y is equal to x times the natural log of b, because that exponent on the b to the x will come out front. Now, making both sides the exponent of e, we get e to the power of natural log of y is equal to e to the power of x ln b. Now, remembering that e and the natural log of x in general are inverses of each other, then that means that e to the natural log of y would be y. And then on the right-hand side, nothing has changed, so that's e to the power of x ln b. Now, if we look above at the very first line, we said that y was equal to b to the x. So the derivative of b to the x would be the same thing as a derivative of y. And down on the next to last line, we have that y is e to the x ln b. So now we have an expression that says the derivative of b to the x is equal to the derivative of e to the x ln b. Now that ln b is just a constant k, so we're going to use that derivative formula that we just came up with. And so that means that the natural log of b times e to the x ln b is a derivative of b to the x. Now we can simplify that using our rules of logarithms and exponential functions, and we just get that the derivative of b to the x is equal to b to the x ln b. So then we have a formula for taking the derivative of all of the exponential functions of the form b to the x. So let's find the derivative for f of x equals 2 to the power of x minus e to the x. So we would need to first differentiate 2 to the power of x, which is clearly an exponential function of the form b to the x. And I've put a little cheat sheet formula up there so we can remember that the derivative of anything that looks like b to the x is equal to b to the x ln b. So I think we're ready now. So the derivative would be 2 to the power of x ln 2. That is a derivative of 2 to the x, minus the derivative of e to the x, which is just e to the x. So now that we've gotten the general exponential functions out of the way, how about something like y equals ln x? Can we do that one? And we can. There's a formula that says a derivative of the natural log of x is equal to 1 over x. So let's find the derivative for f of x equals 8 ln x minus 4 e to the x. Remembering that the derivative of a natural log of x is 1 over x. So we get that 8 times 1 over x is 8 over x. That's the derivative of the first term. Minus, of course, 4, which is just the constant that's there, times the derivative of e to the x is e to the x. Alright, so I think there's only one other form that we need to look at, and namely, since we found the derivative of y equals ln x, can we find a derivative for y equals log base b of x? And of course we can get that one as well. With a little work we could show that the derivative of log base b of x is equal to 1 over the natural log of b times 1 over x. So let's consider this function. Y is equal to pi times the natural log of x minus 4 e to the x plus 2 log base 3 of x minus 3 times 4 to the x. So in this particular example, we have all of the different possibilities mixed together. So let's take it step by step. So the derivative of y with respect to x for the first term would be pi over x. That's because the derivative of natural log of x is 1 over x, and pi is a constant, so pi times 1 over x is pi over x. The second term, derivative of minus 4 e to the x, would be minus 4 e to the x. Moving to the third term, the derivative of log base 3 of x would be 1 over the natural log of 3 times 1 over x. And then, of course, we multiply that by the 2 that's there. And finally, for the fourth term, the derivative of 4 to the x is natural log of 4 times 4 to the x, and then we have the constant of minus 3. So we get finally, after simplification, that dy dx is equal to pi over x minus 4e to the x plus 2 over x ln 3 minus 3 ln 4 times 4 to the x. So just to recap, some important derivative formulas for logarithms and exponential functions are that the derivative of e to the x is equal to e to the x, and from that we get the derivative of b to the power of x is b to the power of x natural log of b, and the derivative of natural log of x is equal to 1 over x, and from that we get that the derivative of log base b of x is equal to 1 over x times the natural log of b.